NORA Heating Fuel Storage Tanks, Chapter 4, Installation Procedures. All heating equipment, including fuel tanks, must always be installed in accordance with the manufacturer's instructions and the regulations of the local authority having jurisdiction. As with all mechanical trades, installation of oil heat equipment requires that personnel maintain a safe workplace, follow industry safety practices, and utilize personal protective equipment as appropriate. The following section highlights and emphasizes some key requirements for a well-installed tank. The recommendations are intended to supplement the instructions published by the manufacturers. The principal focus of these recommendations is to promote practices that help prevent premature failure of newly installed tanks and to promote practices that aid preservation of fuel quality. When performing tank installation and maintenance, always check and comply with the current applicable codes and the current manufacturer's instructions. It isn't practical to have a full set of instructions printed on a tank, so this AST manufacturer attaches a sticker to each tank that emphasizes key elements of required installation and maintenance. Do not transfer oil from the old tank to this new tank is highlighted and listed first because it is so important. This has been indicated as the primary cause of premature tank failure. In some cases, failure has occurred in less than 1 year. The importance of water removal is emphasized in numbers 3, 6, and 8. It is a good practice for technicians to review these recommendations before each installation. Here are some instructions regarding transportation and handling. 1. Never attempt to move a tank with product in it. 2. Tanks should be properly secured and supported during transport to the job site to minimize the possibility of damage. Tanks should be gently handled, never pushed or dropped off a truck. And once at the job site, tanks should be strapped to a hand truck or other suitable device and carefully moved to the installation location. When storing tanks prior to installation, remove the thread protector inserts and install threaded plugs to keep water out. It's best to store tanks indoors or in a weatherproof enclosure. When a tank is delivered to the job site, the installer should check to be sure that the tank has not been damaged during manufacturing or shipping. If minor repairable damage, such as small scratches, are found, it should be repaired according to the manufacturer's instructions before installing the tank. If the damage affects the integrity of the tank should not be installed, and of course always drain water before beginning the installation. Fill pipes and vent pipes must be a minimum Schedule 40 wrought iron, steel, or brass. Galvanized pipe can be used for above-ground tank installations, but it is not approved for use underground. Piping that is part of an engineered system is approved, and cast iron, PVC, and copper do not comply with code requirements. Typically, all threaded joints should be made with malleable fittings, and connections must be made liquid tight using a suitable pipe joint compound. Standard Teflon tape is not an approved compound. If using Teflon, verify that it is approved for use with the fuel. Fuel pipes and vent pipes must maintain pitch towards the tank to prevent traps where fuel can collect. And swing joints should be installed to establish pitch. At first look, the piping in this picture looks good. Swing joints are in place and the piping is clearly pitched towards the tank. Take a close look at the elbows used for the swing joints. They're made with cast iron fittings, which is not acceptable. Code requires malleable fittings. And it should be noted that the 2020 version of NFPA 31 added listed press connect fittings as one of the approved types for fill and vent piping. Fill and vent piping must be 1 1/4 inch minimum. Smaller vents present the risk of overpressurizing the tank, which can lead to failure. Fill caps must be identified as heating fuel tank fills. NFPA 31 reads, "The end of the fill pipe shall be equipped with a tight metal cover designed to resist the entry of water and shall be identified as a heating fuel fill opening." So the fill cap must be identified. Also, the gaskets on the fill caps must be maintained or water will enter the tank. Fill boxes, like the one shown here, should be relocated. This one is in the parking lot and poses a number of issues. It might be difficult for a fuel driver to find, and the weight of the vehicle passing over it is sure to deform the gasket. Fill and vent pipes must terminate outside the building and be located no less than 2 feet from any building opening, intake vent, or electrical meter, and at least 5 feet from any appliance, air inlet, or flue gas outlet. Vent pipes must terminate not more than 12 feet from the fill pipe and at a point visible from the fill location. All above-ground tanks must be equipped with a vent alarm and a gauge. The tank pictured here has 2 issues, one major and one minor. The main problem is that the vent pipe starts out as 1 1/4 inch pipe, but it is reduced to a 1-inch pipe. It must continue to its outside termination in full 1 1/4 inch piping. The second issue is that the tank is not a storage shelf. It should be kept free of debris at all times. The initial fuel delivery to a newly installed tank should be made while the installer or qualified service technician is on site and available to inspect the tank and lines to verify that the system is leak-free, start, test, and adjust the burner, and correct any problems. As discussed earlier, do not transfer any fuel from an old tank into a new tank. Fuel filtering systems do not remove all the microbes that may be present. When it's a new tank, deliver new fuel. Contaminants in aged fuel can accelerate fuel degradation and, in some cases, accelerate creation of a corrosive condition inside the tank. For above-ground storage tank installations, NORA recommends indoor installations whenever possible. And we'll take a moment to discuss why. First, fuel doesn't degrade as quickly when stored at constant temperature. Indoor tanks generate less condensation than similar tanks installed outdoors. Fuel in indoor tanks typically has a lower viscosity due to being a warmer temperature. This can help maximize combustion efficiency. The potential for damage from vandalism or vehicles or even weather is greatly reduced. Indoor tanks are usually accessible for inspection. Often, when an indoor tank is in the infancy stages of failure, fuel odors can be noticed as the tank becomes slightly porous. Here are a few things you might not know. Indoor tanks should be installed on the lowest floor of the building. Tanks should be installed in areas where they will not be affected by household activities. A full 275-gallon tank weighs over 2,000 pounds. The NFPA requires tanks in flood-prone areas be anchored. And drip pans are available for installation beneath indoor tanks to contain small drips from valves or fittings, filter replacements, etc. This next section contains installation considerations for steel above-ground storage tanks. Indoor tanks should be installed on a poured concrete floor. If a poured concrete floor is not present, a 6-inch reinforced concrete slab is recommended. The tank must be at least 5 feet away from any open flame or fuel-burning appliance, and it should be placed at least 2 inches from walls to allow visual inspection from all sides. And there should be no storage either above or below the tank. 1 1/4 inch black iron pipes, threaded on both ends to accommodate flanges, should be fully inserted into the leg support brackets. To provide proper pitch and adequate room for the shutoff valve and filter, the pipe should be approximately 10.5 inches long at the bottom drawer-off end of the tank and 12 inches long at the opposite end. Check all tanks with a level to ensure the tank is tilted to the drawer end and adjust for a minimum of 1/4 inch per foot towards the bottom outlet. The high end should be 1.5 inches higher than the low end. Tank cradles are typically not recommended. Granby Industries instructions say the use of tank cradles is not recommended on any of our tanks. All above ground storage tanks should have an approved tank gauge and one of the tappings on the tank. The use of a combination vent alarm gauge is approved. The fill must be piped to the outside of the building and positioned to permit a spill-free delivery of fuel. Install swing joints, configured with nipples and elbows, to maintain the proper pitch on the pipe. Install a 45 or 90 degree elbow on the pipe outside the building and connect the fill box to the elbow or into a nipple extending upward from it. Position the fill pipe so that it's close to the building and high enough to clear any accumulation of snowfall. Terminate the fill pipe at least 2 feet from any building opening and 5 feet from any appliance air inlet or flue gas outlets. The vent pipe must be piped from the vent alarm to the outside of the building. Install swing joints to maintain the proper pitch. Install a 90 degree elbow on the pipe outside of the building and connect the nipple into the elbow to extend the vent pipe at least 6 inches above the level of the fill pipe cap. Position the vent pipe so that it's close to the building and close enough to the fill pipe for the vent alarm to be clearly heard during delivery. Then terminate the vent pipe in an improved cap at least 2 feet from any building openings and 5 feet from any appliance air inlets or flue gas outlets. Install plugs in any unused top tappings. If the tank has an NPT opening on the bottom and the fuel lines are installed through the top of the tank, it's best to install a valve so that the accumulated water can be easily removed. The valve should be left closed with the handle removed and plugged to reduce the possibility of fuel draining from the tank inadvertently. Install a fusible link safety shutoff valve into the supply 1/2 inch threaded tank bung on the bottom of the tank. Install a fuel filter after the shutoff and connect to the burner with a new coated copper tubing or a steel pipe supply line. Do not use a valve similar to this one. These so-called sludge bypass valves are designed to draw fuel from a few inches up from the bottom of the tank. They leave water on the bottom where it can accelerate tank corrosion. This picture shows a relatively new tank that failed prematurely due to the presence of one of these valves. The rust marks indicate that the tank was properly pitched, but the water couldn't escape the tank because of the stem on the valve. Outdoor above-ground tank installations are similar to indoor tank installations as described in the preceding section. Outdoor above-ground tanks must be installed on a rigid, non-combustible base. Generally, 6 inches of reinforced concrete is acceptable, although in some areas, prefabricated concrete slabs are also permissible. Now, tanks should be attached to the base, and outside above-ground tanks require a vent alarm. Tanks should not be located in places where they may be subject to damage from ice, snow, or dripping water. Look up, check the eaves, gutters, and downspouts when locating a tank. Tanks must be secured and supported to prevent settling, tipping, sliding, floating, or lifting. Special precautions must be taken in flood-prone areas, and ballasting requirements may necessitate a larger slab to ensure that the tank is protected against flotation. NORA and NFPA have developed recommended practices for home heating oil tank flood resistance. A copy of this document can be found at the end of this course. These recommendations are also included in the annex of the 2016 and later editions of NFPA 31. Outdoor 275-gallon above-ground tanks must be at least 5 feet from any adjoining property lines. Tanks must be positioned at least 2 inches away from any wall or structure. Advise the customer to keep this space and the space beneath the tank clear of debris. Horizontal tanks are less likely to tip over than vertical tanks. Let's go back to the first picture, and there were 3 takeaways. Cinder blocks are not considered to be a solid concrete foundation. The dent along the corner of the tank is a sign of overpressurization, probably due to a blocked vent pipe. The main problem with this tank, and the reason it leaked, is that it is positioned right at the chimney with no clearance. The tank developed a leak at this location, where it was touching the chimney, and fuel leaked into the chimney and then into the foundation of the house. Unfortunately, a cleanup was deemed too risky, too expensive, and the end result was that the house was demolished. If tanks are installed in an area where vehicles are parked or where traffic flow is possible, protection from vehicular impact is necessary. Tanks must not block access to doors, windows, utility boxes, or meters, and should be located away from drains or dry wells. Spill protection should be considered whenever an above-ground storage tank is installed. When tanks are installed above ground indoors, the use of tank trays beneath the tank can help mitigate many housekeeping and nuisance calls, particularly when the fuel filter and/or other components are located at the tank. Above-ground storage tank failure is often preceded by tiny tank leaks, commonly called weeping. Any drips from the initial stage of tank failure are easily contained in the tank trays, minimizing unsightly staining beneath the tank and residual odors. The tank tray catches any spillage which occurs during routine servicing and is easily cleaned, further reducing the complaints of fuel odors. Alarms are also available. The alarm is tripped when fuel collects in the tray, alerting the homeowner that a problem exists before serious damage has occurred. It's a good practice to let customers know that these units are available and to recommend them when replacing an indoor fuel tank. Here is a tank in a tray that is long enough to contain drips from the fuel filter during maintenance or from a leak. Outdoor above-ground tanks are subject to additional conditions which can shorten tank life and compromise fuel quality. And these conditions may include severe temperature swings, potential coating damage from adverse weather, and ultraviolet rays. To see what ultraviolet rays can do to a coating, here's a sign, and here's the same sign after exposure to ultraviolet light. They also can be struck by falling objects and subject to acts of vandalism. Installing tanks in enclosures can reduce these risks and help extend tank longevity. In addition, protecting a tank in an enclosure provides some of the benefits provided by indoor installations, including a reduced rate of condensation and reduced frequency of frozen tanks and fuel lines. When installing a tank in an enclosure, remember, fuel lines from the enclosure to the burner should be insulated and installed in a manner that minimizes the potential for damage. Drill penetrations for fill pipes, vent pipes, and fuel lines before the tank is placed in the enclosure. Penetrations must not compromise the containment capacity of the enclosure. If you must install the penetration with the tank in the enclosure, try to drill from the inside out. If you must drill from the outside towards the tank, measure and adjust the drill bit to ensure that it cannot touch the tank, or install a plate between the enclosure wall and the tank to backstop the drill bit. When an outdoor storage tank is being considered, NORA recommends the customer be provided with an option for installing the tank in an acceptable enclosure. In addition to the aesthetics, the enclosure helps minimize the impact of adverse conditions. This next session will address underground storage tank installations. Installing underground storage tanks requires a specialized understanding of the principles of corrosion, an understanding of soil properties and groundwater conditions, as well as a knowledge of safe work practices required for working around and in excavations. The majority of jurisdictions no longer permit bare steel tanks to be installed in the ground. NFPA directs that tanks used for underground storage of fuel be protected by a cathodic protection system or be constructed of corrosion-resistant materials. The use of STI, P3, Act 100, or fiberglass tanks should be encouraged for underground installations. And NORA suggests only those companies that routinely provide underground storage tank services as part of their product offerings install underground storage tanks.